Okay. Okay, so yesterday we talked about two ideas. First idea was how do we find a limit if x is approaching infinity or negative infinity, right? It's called end behavior. So infinity is an idea, we can't plug in the number. Usually we would plug in the number, go from there. But infinity we can't do that with infinity or negative infinity. So we have to have another way. The other way is to evaluate it using three categories: top heavy, bottom heavy, equally distributed, using the degrees, right? The degrees. And then this kind of tells us what the limit would be and what the asymptote would be. Okay. And then we have this little guy up here, which is tells us which ones grow faster, right? So if something grows faster, that's going to tell us top heavy, bottom heavy, or equally distributed, right? Exponentials grow the fastest, polynomials next, log equations, ln equations, then sine and cosine, and then the last one that doesn't grow at all is just constants, right? Constants just stay. Okay, so let's go to the one we haven't done yet, which is D. I think 1D. We stopped right here. Okay. What is the difference between this guy and the three others that we've seen? So it's approaching negative infinity now. It's approaching the other side, right? That's going to change things a little bit, right? So it's like the middle table here, right? We're still going to do the same thing, though. We're still going to do the same thing. Since it's approaching infinity or negative infinity, we're still going to look to see if it's top heavy, bottom heavy, or equally distributed. So I look at the top. Can I factor the top? They have a x in common, right? So 3x plus 1. Can't factor the bottom. Nothing cancels out, right? So always good to check, though. Always good to check. If you can factor it, but because something could cancel out. Well, nothing did. Oh well. Okay? But it's good to check. Next thing we're going to do is the top, the numerator. What's the degree of the numerator? 2. What's the degree of the denominator? 1, right? It's top heavy. It is top heavy. So top heavy says the limit is going to approach either positive infinity or negative infinity. It's going to approach one or the other. So our answer is going to be either one of these two guys. It's not going to have a horizontal asymptote. Won't do it. But it didn't ask us about a horizontal asymptote. But it said it's going to approach positive infinity or negative infinity. Okay, so how do we figure out which one? This is how you're going to do it. What you're going to do is you're going to focus on the guys with the degrees. I'm not worried about anything. I'm not worried about the other stuff. I'm just worried about the guys with the degrees. So you're going to have to do a little mental math here. It's not hard, but a little mental math. If I were to plug in, just inside the red, if I were to plug in a really, 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 really big negative number, would I get a positive number or a negative number on top as an answer? Because you square it and then multiply it times 3, right? So it's going to be a positive answer. Good. What if I were to do the same thing to the bottom? Because it's just x, right? What is a positive divided by a negative equal to? Therefore, our answer will have to be a negative answer, right? Well, the only two options we have are positive infinity and negative infinity. So that means our answer has to be negative infinity. Okay. That's the only difference when it's a negative infinity. You have to take that into account because negative numbers sometimes act different than positive numbers. If it was positive infinity, I wouldn't even need to worry about that, just positive. I'm going to get a positive answer. Because if I plugged in a positive number to the top, I'm going to get a positive. If I plug in a positive number to the bottom, it's going to get positive. So you wouldn't need to take that into account, but only when it's a negative infinity. That's the little hitch there. Okay. Okay, so let's go to the next page and let's look at E now. Letter E. Okay. Can I factor the top or the bottom? No, because the bottom, first of all, the bottom has a root. If it has a root, don't even try factoring it. Just don't even try. It doesn't matter what's on the inside. Don't even try factoring it. Right? The top is just X. So we can't, factoring is not really an option here. Okay. So now, next step is, since it's going to positive infinity, we got to decide if it's top heavy, bottom heavy, or equally distributed. Okay, so what's the degree on top? So let's focus on the guys with the degrees. What's the degree on top? A 1, right? What's the degree on bottom? Okay. So I want to focus just on these guys here. I'm not worried about the 4. So the top is just an x to the first power, right? The bottom is an x squared, but it has a square root. So in reality, it's not an x squared. In reality, what is it? Just an x, right? So in reality, those guys are really just x to the first powers. Okay? That's what it really is. Even though it said squared, it really isn't a squared because it has a square root with it, right? So it really is just a squared. Knowing that now, it's equally distributed, right? So if it's equally distributed, our rule said fraction of the leading coefficients. So what is the fraction of the leading coefficients here? 1 over 1. 1 over 1, which is just 1. Try F. Give F a shot. F is like the one we just did before, letter D. F is very similar to D. So give that one a shot. See what you come up with. I'll give you a hint. Your answer is either going to be positive infinity or negative infinity. No, wait. No, it won't be for that one. Sorry. Because this one's equally distributed. So just try F. We'll go over it, but I want you to just use your table. You're going to use the table. And you're going to use letter D that we did earlier to kind of give you a roadmap. Okay, so the first thing we want to start with, can we factor anything? Is anything factorable? The top is a binomial. Does it have a GCF? No. Bottom is a binomial. Does it have a GCF? No. None of them are difference of squares, so we can't factor. Okay, move on. Now we focus on the degrees. Where are the degrees at? So let's go on top. Where is the degree on top? Or what is the degree, I should say? What is the degree on bottom? So now what I'm going to do is I'm going to try to focus just in on those guys. So what I like to do is I like to just, everything else doesn't really matter to me. Those are the bus drivers. Those are the guys that are going to determine what my answer is. The other stuff is just kind of, they're just there for the ride. Okay, so I'm going to focus in on his. Now, top heavy, bottom heavy, equally distributed. Equally distributed, right? So we're going to get a fraction answer. Fraction of the leading coefficients. But before we do that, we have to take into account that negative infinity. So let's kind of play the game we did for D. If I was to plug in a negative number, a big negative number, the biggest negative number you can think of, if I was to plug it in here, what type of answer would I get on top? It would be a positive. Why positive? Well, because if you cube a negative, it stays negative. And then you multiply it times -3, it's going to become positive. Do the same thing on bottom. If I was to plug in a really, 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 really big negative number on the bottom, just inside the red, would I get a positive answer or a negative answer? Negative answer. Because cubing it doesn't change the sign. So it would still be negative, times 2 would still be negative. So what type of answer am I going to get? I'm going to get a negative answer. Now we said it's equally distributed, right? So it should have a ratio of the leading coefficients. So it should be what over what? 3 over 2, negative 3 over 2. How would this problem be different if at the very beginning I said the limit is positive infinity? Do the same problem, but positive infinity. I'm not worried about the answer. How would the problem be different? What would I still need to factor if I could? Yes. Would I still need to look at the degrees if I could? Will I still need to look at the degrees? Yes. The only part I wouldn't need to do is that mental math part. I wouldn't need to do the mental math part because the top would be negative and the bottom would be positive. That's the only difference when you have something that goes to negative infinity, is you have to do that mental math part. Okay, so if I plugged in a really big negative, how would it do that? Would it be positive or negative? That's the only difference. And in fact, I'd get the same answer because the top would be negative and the bottom would be positive. It'd be negative 3 over 2, right? That's the only, yeah. So that's the only difference between those two. Okay. All right, so let's go to letter G. Letter G, positive infinity. Go back to positive infinities. The top I can distribute, right? I can distribute the top, and the bottom I can multiply out. I'm not really worried about that right now. None of them are difference of squares, so I can't really factor anything. Nothing cancels out, right? So, okay. What's the degree on top? 2. If I were to do this, if I were to distribute, would that change the degree at all? Would it still be 2? Yes. Good. So the degree on top is 2. We're good there. What is the degree on bottom? It's kind of a trick question. So yeah, so the degree on bottom is not yet defined. Why not? Because if I were to actually do FOIL with this, first, that's not first. First, outer, inner, last. If I was to multiply all of those, first term times the first term, last term times the last term, outer term times the outer term, inner term times the inner term. If I was to do all of that, I would get, the powers would get bigger, right? The ones I'm focused on are not, the only ones I'm focused on is the one with the 3 and the one with the 2. If I was to multiply those two guys, I would get 8, right? How many powers would I have? 5, yeah, not 6. I would have 5 powers. Because I'm not multiplying powers, I'm multiplying 4 times 2, and then adding the powers together. Okay? So the degree on bottom is a 5. That's bottom heavy. That is bottom heavy. Okay, so let's go to our table. Bottom heavy says the limit is always 0. Done. Okay. Try letter H. Letter H is kind of like letter F. No, letter E. H is kind of like E. Okay, so factoring is not going to be, we're not going to have to factor here because the top has a square root. So factoring's out the window. But let's look at degrees. What is the degree going to be on top right now? So right now, don't worry about the root. What is the degree on top? 6, right? 6. What is the degree on bottom? 4. Good. So now I'm going to focus just on those terms. Everything else doesn't mean anything to me right now. I'm just focused on those terms. Positive 7 and positive 4. Or positive 7x to the 4th on bottom, positive 64x to the 6th on bottom, on top. Well, the bottom actually is a 7x to the 4th. That's a legit 7x to the 4th. But the top really isn't, right? It's kind of masquerading because it's a square root of 64x to the 6. It's really masquerading as a x to the 6. It's really not. If I was to take the square root of that, how many powers would I have left? 3 powers, right? There's 3 pairs. So really this guy is 8x to the 3rd power, right? That's really what it is. So at first it looked like top heavy, but now it's actually bottom heavy. So because of that, we go to our list, we go to our table, and we find out that bottom heavy is just 0, just like the last one. So the limit is 0. Okay, so what I want you to do right now is do example number 2. I want you to do A, B, and C on your own. You don't have to do D. D we'll do together because D is a little different. But I want you to do A, B, and C right now. Number 2, A, B, and C on your own. Do those as practice. We'll go over them, but I want you to try them. So they ask you for 2 things on this guy. They ask you for not only the limit, they ask you for the horizontal asymptote as well. Okay. Okay, so I put the answers up here so you guys could check your answers, but let's go over them just in case. So they ask you for 2 things. Limit and horizontal asymptote. They're very much related. Okay, so they're very much related. So a lot of the times you're going to get the same answer. So the top is bottom heavy, right? It's bottom heavy. This guy is bottom heavy because degree is 1 on top, degree is 2 on bottom. Bottom heavy, 0. Horizontal asymptote, y equals 0. Number 2, this guy is equally distributed. So you take the leading coefficients, which is 2 and 1, 2 over 1, which is 2. Letter C. Letter C is top heavy. Letter C is top heavy. Okay? But the catch here is it's got a negative infinity. It's got a negative infinity. So we have to kind of do some mental math. Now, you don't have to do a lot of mental math. You just have to focus on the top dogs. These are the guys that we want to focus on. So if I was to plug in a really, 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 really big number that's negative on top, and I was to take it to the fourth root, it's always going to become positive. So if a positive on top, on bottom, I take that number, the negative, the really big negative, and multiply it times 3, which will give me a negative. Positive divided by a negative is a negative. So that's the reason I'll have negative infinity, which makes no horizontal asymptote. Okay. All right. So we're going to do letter D, and then I left some room. I'm going to give you a couple more practice problems. The assignment for this, I'll give to you guys tomorrow. So all we're going to do in class is just the assignment on this. I'm not going to do a new lesson tomorrow. I'll just let you guys work on the assignment for this. So I'm not going to assign it till tomorrow. Okay, but today we have 20-ish minutes. So we'll do problem D, and then I'll give you a few more to try on your own, and then we'll be done for today. Okay. All right. So letter D. We have no denominator. There is no denominator, right? But we have a E. So we can't really decide. It's going to be top heavy, right? It's going to be, if there is no denominator, it's going to be top heavy, right? Because we have a constant on the bottom and we have E to the X. So it's going to be top heavy, right? So by definition, no horizontal asymptote. There's going to be no horizontal asymptote, and my limit is either going to be positive infinity or negative infinity, right? Okay, so let's go back down here. So no horizontal asymptote. Okay. How do I know if it's going to be positive infinity or negative infinity? Well, again, if it was positive infinity here, x to the positive, then I would just say it's going to be positive, right? But we got to do a little mental math because it's negative infinity again. Okay, so if I was to plug in a really big negative here, it would look like this. Negative, that big number, right? I'll just use infinity just to say it's a really big number. It's not really infinity, but it's really big, right? So if I was to plug that guy in, right? And then I was to plug it in over here as well. Would I get a positive answer or a negative answer? Well, let's take a look, right? Let's do this piece by piece. Let's focus on this guy first. It's a negative power. What do negative powers do? Go back to math 3, probably math 2 as well. What do negative powers do? If I have anything with a negative power, what does a negative power mean? Exactly. If you have 2 to the negative 3, it doesn't mean you multiply them. It doesn't even mean, some people think, oh, just negative 8. No, that's not. It has nothing to do with negative. Negative power has nothing to do with negatives. It means really small. Negative powers mean really small, right? So our trick is to move it to the bottom and change it positive, right? Okay, that's what it is. It has nothing to do with negatives. Even though negative powers, you think no, it has negative powers only make it smaller. So really, this guy is 1 over E. Okay. And then I have negative 2 times that really big negative number. What is that going to be? That's going to be a positive, right? One over E to the really big is pretty much what number? So if I have something really small on top of the fraction, and something really, really, really big on the bottom of a fraction, that fraction pretty much is 0. It's pretty much nothing. Watch. 1 over where's E? Biggest number you can think of. Pretty much 0. It's not 0, but it's pretty much 0, right? It's so close to 0 that the calculator's like, you know what? I'm not going to even mess with that anymore. It's 0. Watch when it turns right about there. You see, you come back with the negative exponents again. That means really, really small. Really, anytime you see a negative exponent, it means really, really small. That's what it means. Right? So as I get bigger and bigger and bigger, it's just my calculator saying, no, you know what? Yeah, I'm 0. Yeah, it's 0. So this guy's pretty much 0. So 0 plus infinity is just positive infinity. That's the only change. Okay, and we're gonna do some more. I'm gonna give you about 2 or 3 practice problems to do, and then I'm gonna give you some of those, okay? So here we go. Let's do a couple more. Call this E. So same directions. I want you to find the limit, and I want you to find the limit and find the horizontal asymptote. Okay, so the first one is negative infinity, and it's x over square root. Wait, did I give you this one already? Root x squared plus 4. Let me change it then. Still negative infinity, but let me change it a little bit. X to the 4th minus 1 square root x cubed minus 1. Let's see, letter G. Do those 2 first, and then I'll try to come up with another one that we haven't seen yet. Okay. There we go, 3 problems. Okay, so yeah, let's go over these. The top. All right, so E. The top, the degree on top is x to the 4th, but it's really not x to the 4th, right? It's really x squared. The degree on bottom is x to the 3rd. So the x to the 4th, you're taking the square root. So the square root is x squared, so it's bottom heavy, 0, 0, y equals 0. Okay. F. F is a cosine. So if I was, so this one you got to do a little mental math. If I was to plug in, let me go plug in a really, 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 really big number down there. We just talked about this, right? What would the fraction pretty much equal? 0, right? It would pretty much be 0. What is cosine of 0? 1. So that one you kind of plug in, it's mental math. You kind of just say, okay, so if I'm plugging in really, really big numbers, it's pretty much, that fraction is pretty much going to be 0. It's just what it's going to be. Okay, what's cosine of 0? Just 1. Okay.
So like on that one, like it doesn't even matter if it's bottom heavy.
Yeah, because that's the thing. For this guy, you can't really do bottom heavy or top heavy because it's cosine of 1 over x. So we don't want to look at 1 over x. It's not, yeah, this one it's kind of like the one we did with ease. So cosines, things that don't really have a denominator, you got to look at it a little different. Last one, g. Well, the bottom's x, the top is x, right? Because the bottom has a square root. Okay. So in reality, they're both to the first power, right? They're both to the first power. But it's negative infinity. Wait, let me double check this. It doesn't look right. No, that's not right. Let's see. Sorry, I wrote down the wrong problem. Wrote down. Yeah, I wrote down the answer to the wrong problem. Sorry. So yeah, that's not the answer. Okay, so let's do this one then. Let's do this. So we get, so in reality, it's 4x over regular x, right? If I plug in a negative on top, plug in a negative on bottom, what type of answer am I going to get? Positive. Positive infinity. Wait, no, sorry. That'd be just 4, right? Because it's equally distributed, right? Sorry, yep. Horizontal asymptote, y equals 4. Yep, 4. Mm-hmm. So, yeah, so it would be 4 if it was positive infinity, right? So negative infinity we have to take into account. Okay, so what if I plug in a negative number here and a negative number here? They would cancel each other out and make positive. That's why it becomes, yeah. Okay. Alrighty, guys. Okay, so tomorrow, like I said, I'll give you the assignment. Today is the assignment I gave you 2 days ago. I think we have about 10 minutes. Any questions on that one you want me to do while we have 10 minutes?